Okay, so any questions? Yeah, yesterday we tried to cover a lot of things, and yeah, did you try those some of the exercises? You studied the code?
Yes, sir.
Yeah. So yeah, any questions from the code if anything is not understood or anything?
Select the both the negative amount exception and account plus. Both are written dependent upon each other and
Yeah.
we are unable to compile faster. Then I commented out those and then compile, then recompile.
Okay, fine. So compiling is an issue for you. Okay. Yeah.
No,
Anyone
no,
else? Yeah.
I got it. Like both are dependent upon each other. Like negative
So
amount.
yeah, you can compile them together.
Yes, sir, I compiled.
Yeah. So all of them can be compiled, or still, or you are having comments only.
No, sir, I compile and ran them successfully.
Okay. See, fine. How would you normally compile? Okay. This is important to us. Are these two classes, account class and the other one is the bank class. And okay. And okay. So how do you compile? It's like you extracted the code and then you are compiling it. Let me show how you should do it actually, right? Okay, see here we have the src folder, right? And so when you extracted, you got the src folder.
Yes, sir.
Okay,
SRC and
yeah,
bank
and in this there are those folders for the packages, right? So don't change the directory to any of those folders. Okay, for compiling simply say java c, use the -d option. Okay, fine. And one more thing, if you observe, okay, let me go back one directory. You can see there is one folder I created called bin. Okay, because that's a place where I want the class files to be there. Okay, so all your class files should be in the bin folder. Okay, so changing directory to src where the source code is, right? Here we have the source code with all the package structure. Okay, and so compile like this java c. So always be in the src, not any other place. Okay, and use the -d option to specify the destination folder, ../bin. Fine, I want it in the bin folder. Okay, and what is to be compiled? Okay, I want bank / I can just say star.java or even something like this. Okay, and so it should compile. The other package is the test package, so let me compile that also. And so that's how it should get compiled. Okay, fine. And for execution purpose, java minus, you know this java command is there, right? -cp .. bin, and it's the actually the test folder which has the test account and the test bank. Those are the ones which have the main method, right? So test account. Okay, so that's how it should be, right? And okay, same way to run the other one, which is the test bank, right? Okay, in test bank, it is expecting command line argument. So if I just use like this, it should give a execution error saying array index out of bounds, right? It needs two command line arguments. Okay, so it's for a bank, so testing a bank. So it would be creating a bank object. Okay, we have defined a class called bank. So to create a bank object, it needs the name for the bank from command line. Okay, and some bank code, so some numerical value, integer value. Okay, fine. So if we do it like this, yes, then it should work. Okay, and so clear about running the code. And so any questions here? Yeah. Any questions on the code which is there? Like account.java, any questions here? How it has been done is okay. Everyone has understood what was done. A inner class transaction has been created, and in the constructor of transaction itself, right? If you look at the whole thing, the constructor of transaction is doing certain things, right? What it is doing is the last two things. It's fine that we have instance variables for our inner class called transaction, right? These 4 instance variables. The first one, date, is anyway initialized. Okay, but the other 3, they will need initialization. Okay, but before that, yes, the first check is in the parameter, right? The amount should not be negative, so exception is used here. Okay, and then this is the narration initialization for the 3 variables, and then here is that updation of the balance field. See, balance is in the account class, right? It's in the outer class. How do we access it here? By using outer class name dot this. That's a syntax I have shown here. Okay, and you can access it from the inner class like this. Okay, and same way, the array of transactions, right? That's a passbook is our array of transactions, so that is being updated. Okay, so next transaction in passbook, whatever is the index, and that will be and then you increment it. So put it. So this is the current transaction which has been created. The idea here being that whenever a transaction is created, it gets the balance should be updated and should get an entry in the passbook. So these two are those 2 aspects which are taken care. Okay, updating of balance in the account and entry in the passbook for the account. Okay, fine. So the balance updation, if you have observed, is not allowed from any other place. When balance is updated only one place, and that's the only place from where balance is getting updated. If you have a transaction, then only balance updates. And if you have a transaction, the entry goes in the passbook. And so, see, the entire account class, nowhere you will find balance being updated. Right? See, earlier, like, okay, when there was no inner class, there was like this is a class which has been developed through some changes. So earlier, whatever was there, yes, it was updating, but when the transaction class was created, just call the constructor. So when you call the constructor, balance updation will take place, entry in the passbook will happen. Okay, so constructor, yeah, a new account object being created. Okay, we have the opening balance, right? Same way, the balance updation is happening only with this. Okay, this has been commented, but this is how we update the balance. Okay, so deposit and withdraw method. Okay, and withdraw method is also there in the overridden in the subclass called current account. You have observed that how it is done. Okay, so in the current account, just using constructors use the superclass constructor and the withdraw method overridden in a manner so that if The balance is not there, right? If balance, see, this is saying withdraw as per the superclass. Okay, but if you do not have, so if sufficient balance is not there, it will anyway, superclass also doesn't allow. Balance is there, you have withdrawn, but upon withdrawal, if the balance goes below the minimum balance, okay, it falls short of minimum balance, then apply penalty. Okay, so this is how the penalty has been created. Fine. So entry for a penalty transaction is also done. Okay, when it goes below minimum balance. So this is what the idea was. Okay. Similarly, want to see the bank. What? So is this understood? The code is understood, or yeah, any questions on the code? Yeah. Okay. And any other questions if you have? Yeah. Okay, we can have these to-dos being done. Fine, we'll do it here. But before that, yeah, you have questions that I would like to answer. Yeah. Then we'll begin with this. Yeah.
In this note, can you please open the line number 125?
In which in notes? Which line number?
Yes, yes, please.
325.
225.
225. Okay. Yeah. Okay. Arrays dot sort. Yeah.
Yes, sir. Here, one of my friend pointed out that we have to use like new comparator,
Yeah. Sorry.
give your
Yes. Yeah. It's yes, that's correct. We forgot that. Yeah. Because earlier I think what was done was we had the name comparator as a class, and that is what we were using. But if it is, yeah, that's correct. This should have been here like this. That's the other alternative to using a name comparator. Okay. Fine. Earlier, like I think what we had done initially was defined a class called name comparator. So the code was having that new name comparator, and I think then we forgot this. Okay.
Yes, yes.
Yeah. Thanks. Good. Yeah. Okay. Anyway, but one thing, we will be coming to this syntax later. Okay. Once those function interfaces is done, you should be, I think it's when we look at the miscellaneous classes, that is day 3. Okay. That time, this is what you will be seeing. You should be able to do this. Whatever is this line, this syntax will come up. Okay. And so comparator, you should actually not be, oh, you need a comparator is so simple. If you look at the whole point right here, I wanted ordering by which field? Name. Okay. And it name, I have a get method in the employee class. I can just say employee : get name. Okay. Just for another one, instead of name, suppose you wanted it to be on salary, ordered by their salary. Okay. Now salary would be a field. What would be the type for the salary field? Number, which type? Long or double, something like that? Int long or a double, right? So let's say it is long. Then the change would be only this. See, it's like you want it sorted by a particular field for which you have a getter method. If the getter method happens to be a primitive type, int long or a double, Okay, your method is comparator dot comparing, and that int or long or a double, and just give the class name colon colon and the getter method name. There's no brackets or anything needed. This is a simple syntax to sort employees by their salary. You can see this. Any field which you want it to be sorted on, right? This is how it will become. Okay. Fine, clear. Anyway, we haven't seen the syntax yet. That will be day 3. We'll be reaching that syntax. Okay. When we look at the function interfaces, this is something called method reference. Okay. Yeah. Okay. Any other questions? Yeah. Okay. So before we begin again, something I have for one more question for today. Okay. So we have a question. Okay. Okay, this is day 1. No, we wanted day 2 basically. Sorry. This is day 2. Okay, fine. So this is our question for today.
The two can numbers.
So A, B, C, D. Yeah, these are the choices you have, right? This is just to understand accessibility related to the inner class and outer class. Method 2 is a method of the outer class, right? And method 1 is a method in the inner class inner. Class outer has a variable called x, class inner has a variable called y. Okay. Inside the inner class, we are using variable out.x because out is a parameter, right, received in that method. Okay, so syntax wise, yeah, out.x, right? X is private in the outer class and we are trying to access it in the inner class. So that's on line 7. Okay, line 11 is doing other way around. There is a method in outer which is taking as parameter object of inner. Okay, so in.y we are trying to access the instance variable, a private instance variable. Y is private and inner in the outer class method. So yeah, what are the choice? So yeah, what do you expect?
So I think only line 11 is wrong.
Line 11 is wrong. Anyone else has any other answers? And the answer is C. Okay, both are valid. Okay. What is the meaning of private? Yeah. Fine. Available only within that class. Fine. It shouldn't be accessible outside the class. We have the class. Now, when we are talking about available within the class, we are looking at a class which is member of a package. Which class is the member of package? Outer. Outer belongs to the package, right? Inner class is member of outer itself. So anything inside the outer is available throughout the outer. Clear? The private means the whole outer class is to be considered. Anything within the outer is available throughout the outer. Okay. Fine. Inner is member of outer. So anything in inner is part of outer only. Okay. So accessibility will not be a problem for, so it's not a problem to access a inner class member. Okay. In the outer class. Yes, you should have the proper instance. Okay. You should be, so here we have taken it as a parameter. I have an instance which is an instance of inner class taken as a parameter. In that case, yes, accessing a variable, even if it's a private, it's fine. Okay, so meaning of private, change that. Okay, so when it's an inner class, yes, it's not restricting to the class. It's the restriction is outside the outer class, because outer is what is the member of a package. Okay, so clear on that? Yeah, so any questions? Fine. Okay. Okay. Now, any other questions from the collection framework? We didn't finish it completely, but yeah, we'll have to do it. And okay, how many of you have tried changes? Yeah. Okay, let me first, I think, let me do some of the to-do things there, right? Okay, and we'll, okay, then we'll continue further. Yeah. Okay, so in the account class, what's a to-do? It says override equals and hash code methods. You know what? Why? How do we override equals and hash code method? What is the significance of these methods? Okay, first thing, equals. Yeah, what is the idea?
It returns true or false based on
Equality, right? Okay, so equality of objects is not with the help of double equal to. Fine, you always should be using equals method if it's a reference type. Any reference type you want to know about equality, use the use the equals method. What is double equal to then? If it is the same object or not, right? Okay, being, see, two objects are, you may have two rectangle objects both having the same length and same width. Okay, fine. Then someone should, equality wise, yeah, they are both equal, right? There's no difference, but they are two separate objects. Okay, fine. So double equal to will say false. If it's the same object being referred from two different places, that is what the double equal to will return true. Okay, so that's one thing. So here, yeah, let's do this one. Override equals and hash code methods. Yeah, it's not been done already, no? In this class account. Has it been done? No. Print Facebook account constructor. Getter methods, deposit, withdraw. And we had the private static account constructor override. ToString has been overridden. Acha, equals, okay, it's already done here, sorry. Okay, so the first to do is anyway has been done. Fine. You wanted to return a hash code. Yeah. Now, this is not the way hash code should be done. Okay. You know the relationship between equals and hash code? The whole idea of the equals method here is, we will say that our definition of equality of two account objects is based purely on the account number. So if two account objects have the same account number, we'll consider them as equal. And that is how the equality is being defined for our account class. Okay. Now tell me, what is the relation between equals and hash code?
If equals return true, then hash code will be
Should be equal, right?
for both objects.
Fine. So if equals is true, then hash code must be equal. Okay. So the rule is always, whenever you override equals, also override hash code. Okay. Now a better way of overriding hash code. So let me keep it here. Okay. Instead of doing something like this, we understand it's based on account number, right? Fine. The hash code is dependent. Hash code should be dependent on the account number. Okay. Now, for the sake of convenience, okay, many times people would do something for hash code. They'll say, okay, we have the account number. Let me take modulus of some prime number, and some such things are done. Okay, many times that is how it is done. But you don't have to think of anything. They say, okay, we have provided. So Java library has provided us with a class called objects. So in the Java util package, you will have a class called objects dot, and you can use the method called hash, and then pass as parameter whatever you want. So for example, here it is based on get account number, or you just want to say it's a private variable, you can use it here and just say account number. This should be also fine. Okay, fine. So for hash code, you can do it like this. Okay. Yeah, yesterday I was showing, did you explore and find out and get your hands on the Java documentation? API documentation? This one? You could download this from the Oracle site. Yeah. There is a zip file, some such zip file is there in which it will be available, docs zip file. Okay. Okay, I'll try to get where exactly it is, but okay, in the java.base module. So it's been since Java 9, actually the library is divided into modules, and it has been broken into modules. Modules have packages. Okay, and you understand packages basically. You may not have seen what is a module, but basically a group of packages. Module is made up of a group of packages. Okay. So in the java.util package, see whatever I have used, let me just check. And so we have the classes and interfaces over here. I'm talking about a class called objects. So let me see. Right? We have a class called objects. Okay, so here is the objects class, and what are the methods? Okay, we have this method called, we are looking at that method called hash. Hash code, there's a method called hash code. There's also a method called hash. Yeah, hash. Now, okay, sorry. You can see there's a method hash where multiple parameters can be given. Okay, So multiple values can be given here, and it returns an int. Okay. And so if it's a single value, you can use hash code method also, but the hash method can take multiple values. I hope you are aware what is this triple dot, right? You are aware of this. Varargs, variable arguments. Okay. Okay. Fine. So whenever you have to override hash code method, right, you should refer to this case. Okay. Use the hash method like this. Okay. So that was one thing I wanted. Okay. So we have done that, right? One change which was needed, that is done. Okay. Let's see what are the other to do things. This one is done. Use a list. Okay. This we haven't yet done the list thing. Okay. Add a method called get passbook. All that comes. Implement the comparable interface. Yeah, implementing the comparable interface. Oh, it's done already. I think it's also done. This is also done here. Okay, some of the things have been done already. So implementing comparable is done. The compare to method is there. ToString equals. Yeah, here's the compare to method. Okay, return. See, I have told that all the wrapper classes are comparable, right? So long is comparable. So what we have done is, this is your boxing conversion, okay, casting. And between primitive long and the wrapper long, you can use the cast operator to make the boxing unboxing conversions. Okay, so this was done to convert your, because this is primitive long. This dot get account number is a primitive long. Okay, and therefore this casting was done, and therefore this entire thing is of type wrapper class long. Okay, on that it is comparable, so we are having the method called compare to, and here will be the auto boxing conversion. Okay, this will automatically be converted. Okay, okay, so this was the compare to method. Okay, so I think once we look at the list, then we can convert the array into a list. Okay, so okay, I have updated already on the GitLab. So you have seen that one is to make available the notes. Fine, the notes whatever I have written, I'm writing, they are available on that GitLab. So if you have, you should keep going to GitLab. Fine, and even the entire the PDF which I was displaying yesterday, right? That presentation. Okay, that's also available there. You got that, right? From the GitLab thing? Yeah. Okay. Okay. So fine. So let's quickly go through the okay. Fine. So let's go through this. And what was pending yesterday? Let's check that. Generics was done. Okay. Yeah. That question mark extends thing is pending. Okay. We'll have a look at it, I think. Yeah. So yeah. Have you understood this one? This picture? It's not about list basically, it's more about the wildcard. Okay. Okay. Fine. Okay, let me go back to the notes. Okay. I'll write it here only in the studies thing, right? See, if you have something like this, okay, quick summary of generic. Okay, fine. Say you define a generic class was like this class, right? And some parameters p1 comma p2, right? This is how you define a generic class. Okay, how do we use it? So someone will declare a variable or something, right? Fine. So to declare a variable, what do we do? For P1 and P2, we have to specify the actual types, right? Okay, that's what it was. That's how we have understood it. That it should be an actual type. Okay. Now, when you write methods, have you seen something like this? Okay. Suppose this is part of some method, right? Some generic method. Let me call it as some generic method. Because it's a generic method, it has its own type parameter, let's say t. Okay, fine. I am not bothered about this. Okay. Now, if someone says generic class, right? I want to use that generic class over here. Fine. I want to declare a variable. So for P1, maybe I'm using a string, but for P2, I want to specify t. Is that correct or not? This we call as invocation, right? So this is one thing you understand. One part is the place where we declare parameters, right? This is where you are declaring parameters. This is the place where we have, what have we done? We have invoked a generic type. Just like you invoke a method, you use a generic class, and that we call it as invoking it. Okay, because this is the time where you are supposed to specify the type parameters. Fine, give the actual value for the type parameter. Fine. There is P1 and P2. For P1, it is string. For P2, okay, I have some type parameter available to me. And so that's a type T. That's fine. I'm passing it. Clear? When you write a method, see, it's similar to what you do in a method also. Fine. In a method, you receive parameters and you're invoking some other method, you pass that parameter. Okay. Fine. So no problems with this. Okay, now what has also been done here, so this is one kind of invocation. Another kind of invocation, okay, now let me use that same example. Okay, yesterday I think there was the case where we were saying a list of account. Okay, let's not worry here, and a list of current account. Okay, they are not supertype subtype relationships. They are two different things. Okay, fine. These are invocations. So another way of invocation. So how do we invoke? By using actual type, okay, or by even the type may even be a parameter to me. Fine. So it's some type available to me. You have to specify a type. Okay. Fine. So list is an interface. I'm invoking it with specific type called account. I'm invoking it with current account. I'm invoking it with list of T. Okay. Okay. Fine. Okay. Another invocation which is allowed is I can specify a wildcard. So there are three kinds of things. You can say list, okay, unbounded. Okay. Another way of invocation could be question mark extends and some type. For example, I might say you have done input output streams. Streams you have done, right? Input stream, output stream, Java IO. Some package which has been covered for you. I want something where there is a good class hierarchy available. So, just for that purpose. So maybe question mark extends, and which class will be taken? Okay, if someone writes like this, or yesterday I think we had done that. Right? That's it. Yeah, this is different from what was bounded type. Okay, here is invocation. This is not at all something like a bounded type. Okay, bounded type parameter was different, and some type name. Here it is like number, or here the syntax basically says any data type, any class name or interface name. Okay, in again super also any class or interface name. Super, and I might like to say okay, what does it mean basically? What are these wildcards saying? This one I think yesterday I was mentioning. Fine, anything. This is list of anything. Fine, there's no restriction, unbounded. I should use a variable name here. This is bounded while bounded wildcard with upper bound. And it's called upper bound. Question mark extends number. This is known as bounded wildcard with upper bound. Okay, and the other one here is bounded wildcard with lower bound. Clear? So this is, none of these is basically declaring a type parameter. These are invocations of a generic type. List is my generic type. Fine. In the first two cases, I'm specifying actual exact parameter. Fine, exact data type. In this case, I'm able to use one of the types which is available to me as a type parameter. And in these cases, here it's saying, okay, fine. So unbounded can be assigned. It says unbounded can be assigned any kind of a list. On this side, I can create any kind of a list. On the right hand side, right? We understand right and right has to be fine. It has to be a super type of. It can be a subtype only, right? It cannot be a super type. So this happens to be the super type for all kinds of list. Okay, this happens to be a super type for all kinds of list of numbers, list of number or any subtype of number. And this one is other way around, in the sense this is list of current account or list of anything which is a super type of current account. So current account super type is account. So even list of account is also fine. On the right hand side of this, right? This is okay. It can be a list of account, or it can be a list of object, or it can be a list of comparable interface. Is it making sense that I'm showing the syntax, all the things which are possible for a generic invocation? Okay, you have a generic type, How do I invoke? List of account, list of current account, actual exact data type have been used there. Fine. List of T, I'm using again some type which is available to me. It's not the exact type, but yes, when someone will invoke the some generic method, okay, he will be giving me a type, and that is the type which will be, there is a type available, and that's a type which will be used here. Okay, fine. And this one says, okay, list of anything, any kind of list is fine for me. Whereas this one, when it says question mark extends number, that means number or any subtype of number. List of number or any subtype of number. Fine. And list of question mark super current account means now it's saying list of current account or a list of a super type of current account. Fine. So meaning wise, this is the full syntax wise, like how the various things are possible for invocation of a generic type. Okay, list here is the type which I have considered. Okay, and now relate it with this list of question mark. Okay, basically list of question mark and list of question mark extends object are one and the same, because the object happens to be a super type for everyone. Fine. So first two things are on this. They, you can say, oh, they are anyway super type for all the kinds of lists. Okay, fine. But list of object is one thing. Okay, it's a subtype under the list of question mark extends object, and object has a subclass called account. So list of question mark extends object account is a subtype of the list of question mark extends object. Okay, and list of account happens to be a subtype here. So you can see the relation between list of object and list of account is not a super type subtype relation. Okay, same way, list of savings account is not a subtype for the list of account. And this to show, basically this is just to show that part. Okay, list is here just one generic type. Okay, and the way someone uses the list, because it's a generic, these are the various ways of using list. There is one more way of using list. It is known as raw. Fine. Someone may like to use it as a raw, but no, it's advised never to use it as a raw type. Raw type means even this would be valid if someone writes it, but it's never advised. List L1. List is a generic type, right? And therefore, without parameters, don't use it. It is acceptable just because of backward compatibility. It will start giving warnings first thing, depending on how you write the right hand side. Okay, but if I have an interface list of E, okay, someone has defined list as a, this is how the various usages are possible. Okay, this one is raw. I should have written it as raw. Okay. Fine, clear on this? Okay. So now I think yesterday did we look at the methods of list? Collection we had done, and methods of list. I think in this, okay. Yeah. Okay, these methods we had seen, right? Methods of collection.
Yes, sir.
Okay. So once we have the methods of collection, this default will come to later, right? Because set was same as collection, so that we have to skip. List. List is an ordered collection of elements, fine. So they are accessed by index values, fine, based on indexes. So these are the additional methods. So basic operations, like we had a add method, right? So whenever you add, it always adds at the end, without, if you are not passing the add which is available from the collection interface. We have additional add method where you have to specify index. Okay, so this is used for inserting in between also, right? So you specify the index position where it is to be inserted. Okay, you can remove by an index value. I can give you one simple question, okay, which is related to this. Okay, let me write here. Okay. So if you are looking at a list of integer, okay, we have a list of integers, suppose. Okay. There are classes. There's one most commonly used class is a class called array list. Okay, so someone creates like this, fine, a list is created in this manner, and then someone says, okay, let's add list dot add 45, okay, and then he says list dot remove 45. What do you think? What happens?
It will add and remove the number 45.
In the list? Okay, see, this is what would happen. Now what would happen here is, it's going to give an error. This line will be an error at runtime. You want that number 45 to be removed, right? Okay,
Yes.
then you should cast it as integer. Okay, clear? Otherwise it's an error at runtime. Oops, sorry. Yeah, error at runtime, and then that won't be an error at runtime. Yeah. Okay, why it is an error at runtime? This one.
All this work will take wrapper classes and 45 is not that.
Look at that second method. The remove method is overloaded now. For collection, remove was saying give me the object which you want to remove, right? It will use equals method. But for a list, that if it's a type int, it is used as an index value. Remove from index position 45. Oh, we have only one element. So only index position 0 is valid. No other index position is valid. In our case here, only index position 0. This is trying to remove from index position 45. Okay. So for type int, this is a problem. Okay. If the fine, I have taken a list of integer. Okay. Fine, boxing conversion is happening. Here the boxing conversion happens, right, while adding. This will do a boxing conversion. But here, since a method is available which takes int, it will try to use that method. It won't use the method which is taking object as a parameter. Okay, for that you should do a casting. Fine, so clear on this remove method. Getting by index position, okay, updating at an index position, fine. Then in a list you can pass an object and search what is the index position for an object. Okay, last index of will, this I think we had done this yesterday. Last index of will search from the end. Okay, iteration, yes, we have a list iterator. Okay, and you can go through that list iterator thing. Bulk operations additional, right? We had that add all method in the collection, fine, which will always add only at the end. Now you can insert in between. The entire collection can get inserted at a particular index position. Okay, fine. So this is your bulk operations. Static methods, yes, this is what is used for creating objects. Okay, off. So one thing, you have these additional methods coming from Java 9. Java 9. Okay, so you could just say list dot off, and you have 5 things or something. Okay. Something like this can be done to create a list. But one thing, this is unmodifiable. You can't do names dot add, remove, or any such thing. No operations which can update this. You can only use it. Okay, fine. So this is unmodifiable. So methods like off have been added, off and the copy of. So off method, right? It is overloaded. Single parameter, 0 parameter, or multiple parameters. Or you can use a copy of, and there is some existing collection from which a unmodifiable list can be created. And that was added from Java 10. Okay, clear? This is the list. Right? Okay, list iterator has methods like it is extending iterator. So, but here we have methods to navigate in forward and backward, both the direction. You know, yesterday we saw that next has next methods for iterator. So list iterator has next and next, has previous and previous. Okay, such methods. So we have has next, next, and next index is nothing but if I use the next method, right, I will be getting object from which index position of the list. That's the next index. So initially, if I say next index without using the next method at all, right, it should give me the value 0. Okay, fine. Same way, backward navigation, and we have all 3 updates. Okay, remove was already there, you recollect, remove was there. So you can add a method at the current position. Fine. Set a method, replace what was the last examined object. Okay, fine. So that is what is list iterator. And most commonly used implementation is the array list. The legacy implementation is a vector class. Okay, there's a class called vector which was there. So now we have this to do. So update this. Fine, fine. We'll do that change in the account class. Okay, use list of transaction instead of transaction array. Yeah, sorry. This is the account class, and if you see what all how it was used was this, right? We had the private transaction array. Yeah, this is the private transaction array. So this is to be replaced with a list of transaction. Okay, we'll use the same variable name equal to. I think what I also need to do here is, see, this last index was used basically Next transaction index was because we had an array to keep track. With a list, we won't need this. Okay, so I'm commenting out both of these. Okay, this one as well as this one. New, and we may use the array list. Okay, clear the first change, and then we'll update the entire code accordingly, and you will find that our code is getting simplified because of this. Okay, we'll need one import, so let me add the import here. Okay, and so that's the first thing. Now, what are all the places where we've used the passbook? Let's search that and replace. Okay. So this is the change, and now, so now here you can see, right? We don't need to do this. Okay. What will be the change? It's not an array now, right? So what do? We do the add. Okay. System.out.println. So print passbook is also written. Here we've used the passbook. Okay. For in transaction equal to 0, fine. We don't have to now check for the transaction index. Okay. Since it is iterable, it is for each transaction. Oops. Let me do one thing. I'll keep the old code also. Okay. For each transaction T in passbook. This is not needed. Okay. When earlier these two lines were there, and we have now this line instead of that. Yeah, any other place we have used passbook? No. When done, it is simplifying the things. You can see that, right? Basically, even one more thing which was not done, should have been done, but we didn't do it earlier. In case of an array, whenever the insertion in array was there, we should be checking whether the passbook is already full or not, and then accordingly we should have made the added more, expanded the array. Okay, so if array would become full, what should we do, right? That was not taken care of. Okay, but yeah, we could have written that code that way. So all those complications go away for us. Use of list. Okay, so we have updated this, and we can compile and run the code. It should work the same way. Okay. Well, output wise, there shouldn't be any change. Okay. T is already defined. Okay. Print passbook is the place where we had that, right? Acha, here. Acha, import is needed for objects class. Okay, for the hash code thing. Okay, and output should anyway remain the same. There won't be any change anywhere. Both those classes should work the way they were working earlier. Okay, we can run this one. Fine. So things are working fine. Okay, the change is there for making the thing simplified. And it's getting simplified. This is done now. This is done. User list. Add a method called get passbook to return a list of transaction. Yeah. So okay, this is another one I would like you to do. Add a method called get passbook to return a list of transaction. How do we do this? Sorry. Yeah. Add a method called get passbook. Passbook is okay. Okay, let me do it right here itself. So public method returns a list of transaction. Get passbook. Okay, tell me the code. Yeah. Return. What should I write?
Passbook.
Okay, or this dot passbook anyway. Suppose now there's something wrong about this. What's wrong with returning like this dot passbook? What is wrong with this?
Convert into list.
No. We wanted to return a list, that is fine. Our return type is list. What is wrong with saying return this dot passbook? It's related to encapsulation. Is there any encapsulation now? See, now anyone can call the method get passbook dot add, and he can add any transaction. Get passbook dot remove, get passbook dot clear. He clears everything in the passbook. So what should be done? I do want to return a list of transactions, but I don't want him to update my passbook. Yeah, we don't want him to update the passbook. Okay, so we have this another class called collections. Okay, collections is a class which has a lot of static methods. It's full of static methods, utility methods. So we have methods where you have something like this unmodifiable list. Okay, you can do like this, or what's the other one? This is one option. Or sorry, what did I do? One second. Listen. Yeah. It got it somewhere else, I think. Okay. Yeah. Yeah. What should be done? Instead of saying this, you should say return. What is the other option? List dot off. List dot copy off. Recollect that method, static method copy off, available from Java 9. Okay, this is collections is a class which has been there from Java 2 onwards. Okay, right from the time we have the collection framework, collections class has been there. So this option was there, always there, but the newer option is to say list dot copy off. because this also returns a unmodified. I would mention that this also returns a unmodifiable. But don't do something like this one, okay? Don't do this. Never do this, okay? Return this dot passbook. That shouldn't be done. Clear? This should not be done. Okay, I'm keeping the things so that you can see what all changes were needed. Okay, I mean, what is the correct thing? Okay, this is not correct. Okay, this is, I'm not saying this is not correct, but this is the old thing. Okay, the new thing is to use it like this. Okay, and so we have that collections. Fine, so this change is done. Get passbook method. The idea about putting asking you to do a get passbook method was to explain this. Fine, encapsulation. Don't break encapsulation. So always be aware. Fine. I've seen like people write code where they'll have private variable, which is a data structure which is modifiable, and then you're returning that value, returning that reference to that object. Then what is the use of making it private? Okay. Okay. Implement the comparable interface that we have done. Okay. Okay. This will take when we look at the date time API. Okay. Get transaction stream. These are pending. Add a method called has penalty. Okay. This also we can do later. Yeah. Okay. So yeah. Fine. So this is fine. Now let's proceed with the okay. So what is a map? Yeah. Okay. You have done. Have you got Python also? Have you done Python also? By any chance?
Yes, sir, some of us.
Only some of you. Okay. Okay. Not all of you. Okay. For those of you who already know Python, this is like the dictionary. Okay. Basically, it's a set. Fine. What is a map? Map is more like a set. What was set? What is a set? Collection of unordered collection of elements, right? They have to be unique, no duplicates. Fine. So map is also a similar thing. Okay, I'll explain how it is similar. Okay. Fine. Map is an ordered set of key value pairs. That's okay. Fine. A key value pair is represented by a interface map.entry. So we have a nested interface. In the map interface, there's a nested interface called entry. Fine, that's how it is a map.entry. Fine. It is a generic interface having two type parameters, k and v, for the key type and the value type. Okay. So one entry is one key value pair. Okay. One entry is one key value pair, and map can be seen as a set of such key value pairs. Okay. For those who know Python, it's something like this. If you look at a set, right, a set would be something like saying, okay, 1 comma 2 comma 3, that's a set. Okay, set of 3 values, whereas a map is key value pair, so it's like 1 colon something like this. Each one is a key value pair. So you can see it's a set of key value pairs. It's the same as the set of key value pairs. If you are familiar with Python, you'll see that this is how the set and map are represented. So map can be seen as this. Sorry, in Python you have the dictionary. Yeah, so this anyway. But fine, this is it's clear that yes, this is unique. The key is unique. 1, 2, 3. That's unique, right? We can't repeat. We can't have another one saying, oh, I want to have a 3 colon. No, that won't be possible, right? You can't repeat the key again. Okay. It is unordered in the sense that it's not that 1, 2, 3 is the order in which they will be managed. They are entries for me. Fine. The order, they don't have a specific order. Okay. They are nothing but a key is mapped to a value. Okay. And each entry is accessible easily by its key. Okay. Fine. So this can be seen as, this entire thing can be seen as a map.entry. The type is map.entry. The whole significance of map.entry is, I think in the slide it should be there. A key value pair is represented by a nested interface map.entry. Okay. Interface map.entry happens to be like this. This how I've shown is how they are organized in the, okay. So this is what is map.entry interface. It has these methods. Get key, get value. It has a method called set value. And the return, it returns a V. So what do you think that method is returning? When I say set value, I'm passing a value, right? So what is it returning to me? Can you guess what is it returning? The old value, right? It's returning the old value. What was mapped here? So I'm changing the mapping to a new value. In this entry, okay, fine. I'm changing the value part. Fine. So key is never changed in an entry. Okay. In an entry, key will remain the same. Okay. Value can be changed. When you change the value, it returns the old value. Okay. Equals hash code are fine. Clear? So you may be changing some entry there. Okay. So map.entry methods are here. Okay. Here are the basic operations. When you use a put method, so these are the methods you have. Put method, key and a value. So that's, yeah, what will happen? There are two cases, right? When you use the put method, the first method, put method, if the key already exists, what will happen? See, first method, put method, give a key and a value both, right? It will first see if the key entry with this key exists. If the entry with this key exists, it is going to replace the value in that entry and return the old value. Okay, it returns the old value, put method. If the key is not mapped, it creates an entry and returns null. Okay, put method, if it's returning a null, that means you understand this is a new entry which has been created. Okay, get method anyway, for a given key, I want to get you the value. Remove method, fine, you have given a key, fine. If there is an entry with this key, the entry gets removed. But whatever was the value to which it was mapped, that value is returned to us. Okay. Fine. Contains key to check if do I have any entry which has the given key. In this map, do I have an entry with the given key? In this map, do I have an entry with the given value? So contains value. Any entry with this value, that's what it will search. Contains key is going to be efficient, contains value is going to be inefficient. Okay, fine. Is empty, clear, size, fine. These are simple methods of a map. Clear size means how many entries do I have? How many key value pairs do I have? Okay. And so these are the basic operations. Then we have the operations which return collection. Okay. So you can say, okay, give me all the keys. Okay, here method called key set. Keys are unique, fine, there won't be any duplicates in the key, so it returns a set. Values need not be unique, so it says fine, give me all the values. I'm not interested in the key, but I'm only interested in all the values which are there. Fine, so you can ask for a values, that gives a collection. Okay, and then we have the method called entry set, which gives a set of entries, entry of key comma value. So now this is going to give both the things, key and value both. Okay, fine, but it's a set containing map and entry both. Okay, there is one bulk operation, put all. Fine, so put all, another map is used, another map is, so merging entries from another map into this. So if there are and in the other map which you are merging into this, if there are entries with the same key, okay, then they will be replacing the value part. Otherwise, they should be adding new entries. Fine, clear with the map? Okay. Fine. These are default methods. We'll look at it later. Updating the entire map. These are compute methods. Yeah. So these are methods of static methods of map. How to create a map. Okay. So again, copy of, so that you don't you can be returning a unmodifiable map if someone is returning a map for by any chance. Okay, fine. So these are all these methods which are off or off entries, right? We may try to have a look at the usage of these later. Okay, fine. So you can create a map, empty map, but these are all unmodifiable with the off, map.off or map off, and just give one key value pair, two key value pairs, key comma value, key comma value. That's a sequence. You can go up to 10 entries like this. Okay, the off method is overloaded, so if you have up to 10 entries, you can do it like this. Otherwise, you should go for the method called off entries, where map entry can be it's a map entry dot dot dot. Okay, so multiple entries can be specified, but then how do I create an entry? For that, there is a static method called entry. Okay, I'll show the example of creating a map using the off entries and the entry method. Okay, and creating a map. Okay, how do we easily create it? So it's a map of integer comma string. Okay, and I can say map dot of entries. Fine. See, this is how you should be. You might like to create. So this is something which you might like to do. One. Okay, map dot entry 1 comma. Okay, so something like this can be done, and I've just shown for 3 entries, but yeah. Okay, so to easily create a map, this is how it can be done. But remember, this is when you have an unmodifiable. In this map cannot be updated. Okay, and so that's a method we have. The most common implementation for map is the hash map. Legacy class is hash table. There's a class called hash table. Difference between hash map and hash table is that hash table does not allow any key or value to be null. Okay, whereas hash map will allow one key to be null. You can have one null entry in hash map. Okay, Now sorted map is a sub interface of map which manages entries in a sorted order of the keys by using a comparator. Okay, common implementation for sorted map is the tree map, and you can try that. Update the bank class to use the map instead of account to maintain all the account objects. Update the private method, get account of the bank account, bank class accordingly. Yeah. So we can make the change in the bank class now, because bank was also managing all the accounts by in an array, right? We don't want to use an array, but instead use a mapping of account number mapped to the account object, right? Okay, fine. So given an account number, I should be able to fetch the account object, right? So we should be managing in manner. Okay, so would you like to try this on your own? Okay, I'll leave it as an exercise, and I'll show it tomorrow then, if it's not done. Okay.
Okay, sir.
Yeah. Okay. Here is that collections class. Some commonly used methods on the collections. Fine. Unmodifiable collection, list, set, map. I was using these. Fine. So the old way was to use that unmodifiable. Now instead of this, you may use the off method. Okay. Off, copy off, right? List has the method called shuffle. Not list, sorry. Collections has a method shuffle. Pass a list, it will shuffle the list. So in some of the gaming APIs, you might, gaming application, you might like to use that. You know, shuffling. It's a list of cards, and you want to shuffle the cards. Yes, just call the shuffle method on a. So any list can be shuffled. Okay. Binary search and so many other methods are available. Fine. So explore the API. Add a method called get passbook in the account class to return a list of transactions. This I think we have done already, right? Okay, take care of data encapsulation. The method will have following signature. Yeah, this we have done.
Thank you.
Yeah. Okay, so fine. So we continue with today's thing, which is about the functional interfaces. Okay, fine. So let's move to the next thing, which is a function interface. Okay. These are anyway. Okay, let's move to this. Yeah. So what are the changes in the interface which have come in Java 8? Okay. So you know about interface already, right? So what is an interface? Yeah. Methods. It has methods which are always
abstract.
And always abstract, right? Methods would always be abstract. So if you declare a method in an interface, by default it is abstract. From Java 8, they said, okay, we can even have static methods in them. Declare static, then it's a static method. Okay. Also, you want to write an implementation method. And abstract means we don't write an implementation. So if you want to write a method body, write the implementation for a method, you can write an implementation, then declare it as default. Okay. What do we mean by default is?
If the class implements the method, then the device.
If the class is implementing the interface, it will be able to inherit a implementation for this method. Okay. So otherwise, you know, every method in an interface, class will have to have an implementation, right? So it says, fine, I have a default implementation. Okay. See, what this has happened, what was happening earlier prior to Java 8 was one thing. I think one of the biggest strength of Java is backward compatibility. Compare it with any other language. Fine. Only Java is the one which cares most about the backward compatibility. It will bring new changes. It brings changes. It's fine. It's not that it is not a stagnant language. It has changed drastically. It has come up with new features. But every new feature is taking care that old features do not go away. Anything, any code which you have written earlier should be able to compile and run in the new version without any changes. You should be made to make changes in your old code. Okay, most languages, anything you take, old code, oh, you will have to update them. Here, it's very little change, if at all needed. Okay, so Java takes care of backward compatibility, right? So what was, because of keeping in mind, because that was one of their mottos, that yes, we will keep backward compatibility. So for that reason, one thing what happened was, interfaces were never getting updated. They have given a library, they have given an interface called list. Fine, take example of the list interface. Okay, list interface was introduced in Java 1.2. And when it was introduced in Java 1.2, they didn't think of some methods which would otherwise would have been necessary. Okay, and they came up with that interface. Now, in a newer version, they can't add any new methods into the interface. Why? Because we are giving backward compatibility. If we add a new method, someone who has written implementation of the list, that would fail to compile. Right? It won't compile. So the solution for that came in Java 8. They said, okay, we should be able to add new methods in our interfaces, which we were not doing earlier. So now they have started adding new, updating interfaces also. Otherwise, interfaces, once it was introduced, it was not getting modified at all. No update, no upgrade to an interface was happening. So what they did is, okay, we'll give you a default implementation for the new methods. If you introduce any new methods, we'll give it with a default implementation. So that the old code, which would not have obviously written the implementation of a method which was to come in the future. So for them, there is this default method implementation available. Okay, that's how the word default has come. Okay, and it's a keyword which was used for different purpose anyway. It was used in switch case also, right? So, and even in annotation, it was used as a default. Right? So this default keyword has been reused here also as a modifier for the methods in an interface. So regular methods in a method with body, right, with the implementation, if they were to be there, they would be declared as default. Yes, so now we have method implementation coming in interfaces. Okay, let's see. We have something new. There is something called functional interface. So some of the interfaces, we identified them as, and they said, okay, we have one category of interfaces. If we have those kind of interfaces, we will call them as function interface. We'll see the main purpose. Fine, this is what is adding the functional programming paradigm into the Java language. Okay, we'll see how it is done. Changes in interface in Java 9. Okay, so what Java 9 introduced was private methods. Prior to Java 9, all members in an interface are public, right? Whether it's a static variable, static and final variable. If you declare a variable, it would be public, static, and final because it's an interface. If you declare a method, it would be public and abstract because it's an interface. So by default, all methods are public and abstract. You want to have a static method, declare static and create it. Fine. You want to have a implementation, declare it as default. Fine. And write implementation method. Okay. And then Java 8.9 says, okay, you want to have a private method? Fine. You can have a private method, but not a protected or a default. Okay. Fine. By default, it is public. If you say default, it would mean public. Default means not specifying, right? So if you don't give an access specifier, it is public. But you can have private methods which are static or just private. So what would be the use of these private methods? Where can they be used from? Yeah. Yeah, the methods in the interface, they in turn might like to have some, there is some common code which repeats many places. You may like to put it in a method, right? And keep it as a private method. It's not for someone to call that method from outside the interface, but within the interface, the static method and the default method, they might like to use those methods. Okay, so you can have private static and private. Just say private means it is like the non-static method. Okay, static methods in interfaces, default method, fine. So static methods in interfaces, that's one thing. Default methods in interface we have seen. Lambda expressions, yeah. Something has gone wrong here. Anyway, yeah. So we have lambda expressions. Okay. Yeah. Okay. Come to this. I think that slide has come from somewhere. Does the following code compile? This is showing the addition of a static method, right? So you can write a hello interface like this and run it. And it's a main method, you can run it. Okay, so prior to Java 8, this would not have compiled, but Java 8 onwards, this compiles and this can run. Okay, from Java interfaces can have static methods, right? Yeah, enhancing the interface without breaking backward compatibility. That's where the default methods are. Okay, now what is a function? Yeah. How do you look at a function? What is a function? Yeah.
Like some block of code doing.
It's a block of code, right? Fine, which has some inputs, fine, which are nothing but some parameters, and may return a value. Fine, it does the processing and returns a value. Okay. Fine, possibly returning a value. Return type void means not returning a value. Okay, so those are nothing but your functions. Now what it says is from Java 8 onwards, functions are first class citizens of the language. And what do we understand by saying it's a first class citizen of the language? Okay, so to understand that, we'll talk about what is a function interface. Yes, what is a function interface?
An interface that contains only one abstract method.
Fine, one abstract method. Okay, fine. So yes, broadly one can take that as it is, this statement. Okay, but there's one small caveat to it. Okay, so one small correction which may be needed. Okay, I think do I have I put it here? One second. Okay, just one thing to remember is when you say okay, for that let me give an example, then I think it will become more clear. Okay, so function interfaces. So other than the abstract method, other methods can always be there, that we understand, right? But abstract method count should be one. Okay, now we have the following interface in the Java library: public interface comparable of some type T, and it has declared abstract method like this. So if I don't put a modify, it means because it's an interface, it's an abstract method. And we have the compare to method, which takes as parameter T. Okay, but it also has another method which is saying int hash code. Yeah. So tell me, this has got how many abstract methods? Is it a functional interface or not?
Yes.
How? It has to be having single abstract method, na?
Maybe sir, hash code implementation is in object class.
Okay, you ignore the public methods of the object class if they are declared as abstract. Okay, fine. So this is correct. It's a function interface. Okay, you don't count this one because this happens to be a public method of the object class. But if someone has put like this, then this is not a function interface. This one is a protected method, and it's a method of the object class, but it's a protected method. So you don't count the public methods of the object class. Other methods, if there are abstract methods, you have to count them. Okay? And so that's one small thing which you should always keep in mind. Because we have many such interfaces, they have these methods from the object class coming into it as an abstract method. Public methods basically. Which are those public methods of the object class? Yeah, which are all the public methods of the object class, not the protected ones. And one thing, they shouldn't be the final methods.
Where the toString and
Public string. Okay. Equals, which takes object as a parameter. Okay. We have just taken that, right? Yeah. Other methods are all either protected or they are final, right? They are final methods also, right? You're aware of all the methods, no? Final methods, because final methods anyway, no one will be able to provide in the interface. Fine? You cannot put them in an interface. What is final in object cannot be put in the interface. Okay. Anyway. Yeah. Okay. So fine. So this is one aspect. Now coming to functional interface. So functional interface is fine. Now coming to lambda expression. Okay. So what is the lambda expression? Yeah. It's a
anonymous function.
Okay, you are calling it as anonymous function. Okay. It's an implementation of the it's simply just an implementation of the abstract method of an interface, function interface. A function interface is only one abstract method, so that abstract method's implementation is what a lambda expression is for. Fine. But one thing, it is also an object. Fine. Okay, it is an object of the type of a function interface. Okay, simple example. Okay, we have a function interface, some ready-made. I'll use some function interface from the library. Okay, see one thing. What has been done here is we have a whole library of function interfaces. one more, we have so many concepts which have been added in the language at a later stage. But old code has the function interfaces already, right? Okay, fine. So old code is there where there are a lot of function interfaces. One more thing. Okay, now you know the syntax of a function interface, a lambda expression. Syntax of lambda expression. What's the syntax? Parameter list. Okay, fine. Parameter list, lambda operator, and you have a block where you write the fine. Okay, if you don't have a block, if you have only a single statement, these statements in these statements must if the functional interface for which you are writing this expression, okay, you are writing the lambda expression corresponding to a function interface. If that abstract method has a return type other than void, then you should be having a return statement. Okay, fine. Another thing about the parameter list. Okay, I'll take one example of a function interface. There is one standard function interface called int binary operator. Okay, fine. We have a int binary operator as a functional interface. Okay, let me put it how it has been defined: public interface. It's not the exact. Fine. There are many other things. Interface, int binary operator, and though it extends from some other interface, I'm not writing it currently here. The purpose is only to know what is my method in this, right? I have a method whose return type is int, abstract method. I'm only mentioning the abstract method. I'm not writing the other kind of methods. The abstract method which happens to be in this is okay, takes two integers and returns an int value, right? Okay, there are other kinds of methods that I'm not writing. Okay, also it extends from certain other interface. I'm not mentioning that. Okay, but this is how it is. It's a function interface with one method called apply as int. Okay, fine. So if this is the case, you may write a lambda expression, right, which can be like this. So you can say int binary operator, okay, f1, my function 1 equal to, and I'll say int a comma int b, okay, and I can write saying return a plus b. Simple thing. Okay, I'm just doing addition, that's fine. It could have been some other thing which I'm doing. Okay, fine, clear? This is the first syntax, first cut. Now we can cut down on this syntax. Okay, since we know it's an int binary operator, the parameters will be of type int. I need not specify them. I can write like this. Okay, fine. Another thing, since it has only a single statement, I don't need the braces. But when I don't put the braces, I shouldn't be putting the return statement as well. Fine, return cannot be, you can't be writing as a single statement, don't use return, just put the expression which is to be returned. In case of a return type void, yes, you have to write a statement as it is. Okay, but our int binary operator, the return type is int, and therefore it would be like this. Okay, so this is how it can be, right? Okay, single statement, which is just a return statement, then just put the expression for that. If it's not, if return type is void, then the statement as it is. Okay, here our example does not have return type void. Okay, now, okay, one thing we understand, object is the super type for all reference types. Right? Everything should be assignable to an object. Okay. So whether someone says object obj equal to, and maybe even if someone writes like this, okay, this is a full syntax. Is this valid? Can I do like this? What do you expect this statement? Can I assign a lambda expression into an object?
Yes, sir.
Here the answer is no. This is not going to compile. Okay. Here, okay, here when you write this, the left, whenever you use a lambda expression, it will try to infer what is the type of the lambda expression. Just think, you already have so many, how will you know what is the type of this? What is the type? Is it an int binary operator? What do you think? This is int binary operator. Is this an int binary operator?
No, sir.
What is it? It could be any interface which has the single abstract method which takes two integers and returns an integer value. It qualifies for any such functional interface. There are multiple functional interfaces which have the similar signature of the method. And a lambda expression only having a method signature, not even the method name. And even if the method name is there, or two interfaces with the same method name, with the same method signature, they can always be there. So you don't know what is the type. So lambda expressions on their own do not have their type. It is always inferred. The compiler infers it from where it has been used, how you have used it. Fine. So in the earlier case, okay, in this case here, it is inferring from the left hand side, oh, this is of type int binary operator. The lambda expression here has a type which is int binary operator, because my left hand side is saying int binary operator. What you have written is matching that signature, and therefore this is an int binary operator. So fine, but here in this case, if you want this to compile, what you should be doing is casting. Then this will compile. Okay, fine. Clear on this? Type inference has to be done for the lambda expression, which functional interface it is. That has to be known to it. It determines it from the context how it has been used. Clear how it has been getting used. There is something called type inference. Okay, so there is type inference involved for lambda expressions. Okay, fine, clear on this? Okay.
Yes, sir.
Fine. Now, from syntax point of view, you may just like you have an int binary operator. I might take some other example. So only thing is you might okay. Just like int binary operator, there's a int unary operator also. This just as an example. Int unary operator f2 equals, and someone says okay. So you could be saying int a and this, and you will be saying okay, return a plus 5, something like this. Okay, and so this is valid, and this can be reduced. So this is also equivalent to saying okay, and this is also equivalent to saying, the point I was trying to point out here is you could even write without this. If there is a single parameter, okay, you don't need the parenthesis. Okay, rest of the things similar to what we did in the earlier case, we can remove all of this. Okay, put only the expression part. Okay, and so these are all valid syntaxes for the lambda expressions. Clear about the syntax of a lambda expression now?
Yes.
Okay. Fine. So this is we have lambda expression. So now fine. By showing that object class and that type inference and everything, one more thing which is coming to significance is that a simple just a lambda expression on its own, no, it doesn't make any meaning. Okay, types have to be there, and if someone writes a lambda expression, always we need to be knowing what is the function interface. There has to be a function interface type corresponding to it. Okay, without a function interface type, we cannot have a lambda expression. Okay. Okay, now there is one small exercise which is part of what but anyway, we'll take up the exercises later. Fine, which are the changes in that account and the bank class. Okay, actually it's supposed you are supposed to define a function interface for the penalty. If you look at that code for the current account class, it uses a penalty which is applied whenever there is a whenever you go below the minimum balance, right? So that is a fixed value. We don't want it to be a fixed value, but rather as a we want it to be a function, which is a function of what is the minimum balance which is supposed to be there, and what is his current balance. So how much is the shortfall? Depending on the amount of the shortfall, the penalty will vary. Okay, so we want it to be a function of the balance and the minimum balance. So we can take it up later, but anyway, such exercise is there. So converting fixed value into a function, that's what the whole idea was, that yes, lambda expression or a function interface represents a function type. Okay, fine. Single abstract method is our function. Fine. Okay. Fine. Let's see. Okay, examples of function interface: action listener, runnable, comparator. Yeah. See, I'm not putting comparable here in this list, though comparable also as a single abstract method. Syntax wise, yes, if someone says this is a lambda this is a function interface, then it is fine, but never will ever be someone using it a lambda expression for a comparable type. Okay, because what is comparable? It's supposed to be an implementation for a class whose elements need a comparison logic. So independent of the class, it cannot be given. It has to be always a method. Compared to is a method available as part of a class definition. Okay, it cannot be done independently. One second. Lambda expression is a function. Yeah. Function type, example, binary operator. Yeah, we have the int binary operator. This is what define a function interface called penalty, having abstract method compute, which takes input parameters minimum balance and the balance and returns the computed penalty. Okay, this is our exercise. Update the current account class to allow setting of a penalty as a function instead of a value. Okay, also add a method to set the penalty function. So I would like you to try these on your own, and tomorrow we'll take this. Okay, and I'll show it in our code. Fine, we'll update our code here. Okay, add appropriate constants and static methods in the penalty. This also, yeah. Let penalty extend from the. Okay, so these are some of the things, yeah, which you can do. Okay. Use a lambda expression to set penalty function on a current account object. Okay, and yeah, syntax of for method reference. Acha, this is functional interface. Now here is syntax for a method reference. Okay, So lambda expression is fine, function interface and lambda expression, two things should be okay. So any questions on these two things? Understanding of function interface and the lambda expression. So if lambda expression is fine, then we can proceed to the next. Yeah. Okay. Or yeah. Any question?
Oh, sir, we can proceed.
Okay. Fine. Next is sum of the lambda expression can be using a method reference. Okay, so we can use method reference in cases of some of the lambda expressions. Some lambda expression can be represented as a method reference. So not all kinds of lambda expressions can be. Okay. These lambda expressions involve only single method invocation. So there is a lambda expression, it's only doing one job, that's I'm just invoking a method. Okay, but it has to be in a specific manner, only in which case you can use a lambda expression. So let's check those examples. Okay, so there is a method reference, the syntax for the method reference and all will come. Okay, and for example, let me consider some I'm not writing a function interface here, but we assume there is some function interface corresponding to this lambda expression. I'm just writing only the lambda expression. So maybe I have a lambda expression which says some type 1, okay, A. I'm specifying the full syntax, so I'm specifying the data types, okay. There is a type 2, that's B, okay, there's a type 3, that's C, and then we have a lambda expression. What is our lambda expression on the right hand side? It should be something which is a single method invocation. So it is saying A dot, okay, on the first input parameter. The whole idea here is on the first input parameter of the lambda expression, fine, of the lambda, the parameter list, on the first input parameter, I'm invoking some method which uses rest of the parameters in the same order. Clear? There are 3 parameters in the lambda expression. In this basically in this the lambda expression involves 3 input parameters, right? So the first parameter is the one. My expression says, okay, on the first parameter, I want to call a method, some method which is a. So this is obviously some method is a method of type 1. Okay, some method is some method available for whatever the type 1 is, right? And the rest of the parameters are B and C. Okay, that I'm taking as inputs to invoking the sum method. Okay, fine. In which case, okay, this can be written as okay, and here is how it can be written. You can just write it simple, type 1 colon colon sum method, no other thing. Okay, okay, and now give you an example. This example will involve okay, now okay, this example actually requires some of the standard function interface, right? Okay, we'll come to that. Is this okay? If this is the case, I've just taken one example where we have three things like this. Or see, instead of 3 parameter, if we had a lambda expression with only 2 parameters, let's say. We had some lambda expression, so there is some function interface where there is a method with 2 inputs and it is returning some value, and for returning that value it is just invoking some method. Okay, so there is some other method, fine, of type 1 which takes one single parameter, and here it's just invoking that method with the second parameter which is part of the input. So this can again be represented as, you will say, type 1 colon colon. And so our first example is about a method reference where on the first parameter, the whole point is on the first input parameter, okay, fine. Whatever the number of parameters, fine. If it has only one parameter, so it's not passing any parameters to the method, right? Passing the rest of the parameters in the same order. Okay. Yeah, in the same order. Okay. When clear, so this, in which case it becomes type, whatever is the type of that first parameter, colon colon, the method to be invoked. Okay. When later we'll see examples of using method reference, and you will find that it is so good to use method reference. Okay. If you recollect that sort method, arrays.sort, what I had done there was I had used a method reference. Employee colon colon get name or get salary, yeah, and that was used in the sort method. Comparator dot comparing, and then employee colon colon. So employee was the class, colon colon, in the method name. Okay, we'll see why and how it came to be used in that manner. Okay. Here, this is the first case of, so there are multiple cases. First case is like this. Okay, so case 1 is this one. Okay, clear? What we have discussed is that case 1. If you want, now the second case is invoking a static method, or yeah, fine. So if there is a static method, and so static method invocation. So if there's a static method invocation, maybe you have a lambda expression. I'll again take example with 3 parameters, a comma b comma c. Here that type may not be necessary. Okay, so there is some other type 1. Okay, dot static method of type 1. So okay, let me have, and a comma b comma c. If this is what someone is doing, right? If you have a lambda expression where you are invoking a static method available in some class or an interface, I just put it as type 1. Okay, fine, and using the parameters in the same order. If just that is what is to be done, okay, fine, it can be written as, now you can know what is the lambda, what is the method reference. What will it be? Okay. Fine. So if there is a static method, yes, then which is being invoked in a lambda expression, and that's the only thing it is doing, yes, then you can do it, write it like this also. And it has to be the one which is using all the parameters in the same order. Okay, fine. A third example. So this was case 2. Actually, I should have put the case number here. Case 1. This is case 2, and this is here. I should. This is case 1. Okay, we have case 2. Now let me go for case 3. Okay, fine. In case 3, method invoked on some object. And uses all the parameters in the same order. Okay, fine. For example, there is some object available in the given scope, and you have got 3 inputs. Okay, I've just taken an example as 3 inputs, could be whatever the number of inputs, right? And I have some object, okay, some object which is available, dot, okay, method available on that object. Okay, fine. And it says a comma b comma c. If this is the lambda expression, okay, the method reference will be, so in this case we don't start with a class name but rather that object, and then give colon colon and give the method name, whatever that method name. Okay, so 3 different cases for a method reference like this. Okay, when again we will be having example where we use it like this. One of the very I'll write one example, though these examples you will be seeing these examples much later being used, yeah, because we have to look at the these standard function interfaces. Once you have seen them, then we'll see in the API where they are used, those function interfaces, and then we'll have examples where we will be able to use them, use method references. Okay, and so some example for this kind of a thing. Okay, in our exercise somewhere you might come across something like, okay, okay, see this is for something which says given an account AC.display. If someone was writing a lambda expression like this, given an account, I just want to do a display. Okay, fine, account colon colon display. Okay, same way here a very commonly used thing is system.out is an object which we know, colon colon, and I'm calling the println method. So I have one input parameter, maybe it's an account object, and someone saying system.out.println AC. Okay, so this is the equivalent lambda expression for it. Sorry, this is the method reference for this lambda expression. Okay, so this is some lambda expression you'll come across this one, but it would be more convenient to write it like this. Okay, now just like we have a method reference, we have something called a constructor reference. Some people even call this also as a method reference. So it may be referred even as a method reference. So some more cases of method reference, but these are we call it as a constructor reference because they involve creation of object. Okay. So if someone has a lambda expression which is like this, a comma b comma c, and says, okay, new, and I'm creating object of some class, and I'm just calling the constructor and returning the object, right? So a constructor using all the input parameters, or even if someone has something like this, new, okay, let me write like this, array list. Suppose this is what you have written, right? This can be written as array list. Okay, so fine, this one which is more general, I'll just say some class. Okay, so these are, I'm just showing the method reference for a corresponding lambda expression. Okay. Here we call it a constructor reference now. Okay, so in constructor reference it will be colon colon new. Also there is one more special case of a constructor reference, okay, which is where the input is always of type int. Okay, so let me mention it. So int size, and you have a lambda expression which says, okay, let me return, not we won't write the return statement in any way, but we are just saying, oh, let me allocate an array and return the array. So array of some type. Okay, this may be some type, and array of the size. This is what I do. My input is a integer value which gives me the size, and given a size, so I have a function which given a size, it returns an object of some data type. Okay, array of object which is an array of a data type. Okay, so this is equivalent thing here would be okay, right, or your input would be the size. Okay, let me take it this way, new, I want to allocate an account array of the size and return, right? So this would be clear. So these are what we call as a method reference and the constructor references. Okay, yeah, now let's come to the standard function interfaces. Okay, see, our library contains so many classes and interfaces already. Even before Java 8, there were so many things which were there, and there were so many interfaces, and which now are qualifying as functional interfaces. And many of those function interfaces, their method signatures would match. Okay, fine. But what we would always prefer to do is to have some standards, right? So we would like to have some standard function interfaces. So most common, see, function interfaces, you are saying, okay, it's a anonymous function, right? But these functions, they have a signature. There is a function method signature. Okay, and lambda, if you have observed, the whole thing about lambda expression is the one who writes the implementation of the method need not know the method name. Have you observed this? When you are writing a lambda expression, you don't even know that the name of the method in that was apply as int. When we wrote a int binary operator, it was apply as int, right? That method name. But when you wrote the implementation, you are not knowing the method name. You only know the signature correctly. Okay, so everything is mainly identified by signature, right? But who needs to know that name of the method? Not compiler.
The one who call.
The one who has to call. Okay, let me now explain one more aspect now, because this is again another mistake which very commonly happens about the understanding. Okay, so I'm writing a code involving a lambda expression. Okay, so I'll just write a lambda expression. Let's see this code. So maybe it's, let me take the example of int binary operator only. Fine. So someone says, oh, I have an int binary operator. Okay, this is my function one. So I'm creating one function equal to, and I'm saying, okay, I have A and B, and in the lambda, and now I'll write multiple statements here. Okay. In these multiple statements, I'm saying, okay, let me do a system dot out dot println. Okay. Okay, maybe just something to be printed, right? And then I'll say, okay, now let's return A plus B. And a simple thing like this, sorry. Right. So this is one statement which is getting executed. This statement is getting executed. So what happens in this statement? Will it print received A equal to and some value? What is the effect of this statement? This is one statement, right? What is the effect of this statement? Yeah?
Sir, A can be string or integer maybe.
No. A will be, because it's an int binary operator, the type is int. What is a lambda expression? What is this? What is this? Is this statement going to execute it? No. This is not executed. This is a function being defined. It's not the execution of a function. Lambda expression is about defining a function and creating an object of that. This is a function definition, which is now available in F1. This statement never executes a function. It defines a function. Here, lambda expression is a definition of a function. Creates an object which has the, so it's an object for a function definition. What is that function definition? This is my function definition. And this function definition is available in F1. You want that thing to be printed, F1 dot apply as int. Pass a value. Unless there is a value, there is no thing to be printed. Clear? When you see something code, don't think it's a place where it is executed. You normally have a tendency, oh, this will be executed because I've written the code here, it should execute. No, it's not about execution. A lambda expression is about defining and keeping it in an object. Defining a function and creating an object for that function definition. Okay, lambda expression is creation of an object which has a function definition. It's not about executing that function definition. The one who is defining the function is not knowing the name of the function, doesn't need to specify the name of the function rather. May or may not be knowing, that's a secondary aspect. Fine, clear on this now? No? See, F1 has one function definition and F1 later can have a different function definition. So if someone calls F1 dot applies int at another point of time, oh, there is that whatever is the function definition available through the object available in F1. F1 has some object, which is a function. The type is int binary operator. a function interface has a function type. Yeah, getting it or not?
Yes, sir, if you put the F1 not applies itself into a print line.
Then this is where it will be printing. This is what is going to execute that function now.
But it
Okay, fine. So someone has to call the method. You create an object and then you call the method. Okay, see now you are saying arrays dot sort, right? What do we call? Okay, we say employees. And then what do we do here? We say, oh, let me create an object of name comparator and give it to you, right? This was one thing we did. Instead of saying name comparator, we said, okay, let me create one object of the anonymous class. And we said name new comparator. And I have a definition in which I'm writing the definition for okay. So here you are saying public int compare, right? And you're saying employee even. Fine. I'm not writing the code for this, but you understand, right? There is some code. Okay, fine. So in this case, what are we doing? We are passing a function definition, right? An object which has a function definition. And we were never calling that compare to method. Were we calling the compare method? This object is created which has, if you call the compare method, you will have to pass to employees to call that compare method. So this is one function definition which I was passing. Now what is the option available? Comparator is a function interface, and I am doing something like this. I'm not creating the object in the manner in which it was done earlier. Oh, yeah, we will have one braces will be there. Okay, but I don't have to write the method name now. This is a lambda now. And for that lambda, I don't have to give this. See, the context says the method signature sort requires a comparator of employee. And therefore, this is, I have inferred that this is actually a comparator, a function, lambda expression for a comparator. Okay, and if you want, you can even write the expression without the whole thing. Single statement can be there, whatever you are returning, right? E1 dot and whatever, right? So this can be your code. Right? There is some code here which returns a int. Okay, clear? So when you do this, yeah, the sort method actually is the one which was using the compare method. Right? It is inside the sort. It has received the object of see. Okay, what is how is the public static void sort method, which is part of the arrays class, right? It has said, okay, you give it's having a type parameter t, and it says, okay, you give me an array of t, and I will be receiving a function. okay, which is a comparator function, right? Clear? And it is this who will be using internally, it will be saying, okay, see, somewhere it would say compare dot compare, okay, and it will be using array of I, comma, maybe if it's a bubble sort, you might be using array of I and I minus 1. Okay, I minus 1 and I probably, something like this, you may be comparing. Right? Adjacent things you might be comparing. So if this is compare this is greater than 0, right? I would like to do a swap. And that's a code. Yeah, it's not the whole code which I have written, but yeah, you understand this. This is where the function is used. You are passing a reference to a function and the function is called by someone else. The one who defined the function is here. He's the one who says, this is my function definition, which is to be used. And who's the user? The sort method has taken a parameter where it is accepting a function, some function definition. The call to the function is here. Isn't it? Clear? So where you are defining, this is where you are defining, creating the object, creating the definition. It is used by someone else later. The one who is, so lambda expression is defining and creating an object. Just defining a function, not execution of that function. You see the function code, but that's not executed. That's defined. Clear about that difference?
Yes, sir.
Okay. Yeah. So fine. Now, just as an exercise, I think we will be. Yeah. Okay. Just as an exercise, we do have some exercise, but would you be fine? You should find time to try it out, the exercise. Okay. I would like to show the code, but that I'll do it tomorrow once you have tried it. Okay. Fine. It talks about a interface called penalty. So, which is a function of minimum balance and balance. Right? So you define that. You declare a function interface first. Define a function interface, declare it. Okay, so you will have your own function interface. Let me give some idea like this. So what you should be doing is public interface penalty, or you may call it as penalty function. And this may say, yeah, what I need here at least would be that I need one abstract method which is returning long, method name is compute, parameter, a long for the minimum balance and another long for the current value of the balance. And so this is my function. Okay, this is penalty function is a function type. Clear? And it represents a function which takes too long as input and returns a long value. Clear? So if you have this, then someone will be, then so what is needed later somewhere is that yes, you will declare that okay, that we have that, you know, something like we had earlier got public. I think there was a variable, I'm not sure what access it is, but there is something of type long. We have something called penalty equal to, and some value was there. For example, penalty equal to 500 or something like that may have been there. Fine, something like this was there. Okay, so this we don't want to use penalty as a fixed value like this, but rather it should be Okay, maybe continue using the same variable name, this we will get it commented. Okay, and equal to, here you might put a lambda expression which it becomes a default, but we would allow it to be changeable so that a new penalty function can be set. This is penalty function. Okay, penalty function. Okay, penalty equal to, and you can have your lambda here. You understand now the lambda, how to write a lambda, right? Okay, fine. So this is what needs to be done. Okay, something on these lines. So just think about it. Fine, I'll give you. So you try it first. Okay, then we'll see how we'll change, update that code. Okay. Now the next part here is about some. Okay. There are some standard function interfaces. Okay, so we've got a standard set of okay, which are available in java.util.function package. Okay, these cover most commonly used method signature. Okay, because we understand lambda expression is all about method signature. Okay, fine. So here so the package is java.util.function, and it contains, there are 43 function interfaces over here. Okay, one more function interface which is from the, which you can say is a standard function interface, but not part of the java.util.function because it's already there in the java.lang package, is the runnable interface. Okay, so runnable is, I'm not discussing it here. Okay, but yes, we have we have java.util.function has 43 functional. Okay, we categorize them into different categories. Okay, so based on the kinds of method signatures they have, so we have got those kind of functions which take input parameters but do not return a value. That means return type void. Okay, so we call them as consumers. Okay, where we have method return type void are consumers. Okay, fine. And we got how many consumers? Okay, let's see how many consumers are there in the standard function interfaces. So our standard function interface, we can start with the first one, which is a consumer of a one more point here. We normally, this API will normally cover from the primitive types, they cover int, long and double. Right, the primitive types int, long and double are covered. Float is never to be used. Understand this, you should never be using a float anywhere. Do not define functions where you are using float. Okay, fine. Byte, char, short, they always, for all purposes, they will be getting converted to int when they are involved in some expression. Right, so it is int, long and double. These three primitives only have been considered for our standard function interfaces. Okay, so we have one generic interface which says, okay, we have a consumer of some type T. Right, so this is one. Okay, we have got something called int consumer, we have the long consumer, we have the double consumer. Okay, fine. And then we would have a by consumer. By consumer, then it should have two inputs, T comma U. Okay, Now 2 input can be again with the help of combining them with primitives. So we have something like obj int consumer of, obj means some type t. We would have obj long consumer of type t, obj double consumer of type t. Okay, so that way you can see there are 8 different consumer types. This is what is available in the standard function interface. Now what is common about all of them? Return type void. Okay, fine. So one thing, the method, what are the method name? We don't know the method name yet. Okay, the method, right? Accept. Okay, they have the method called accept. Fine. And return type void. What else is needed? Yeah. So the abstract method is going to be like this. Okay, so all of them have the abstract method called accept. Parameter. Now you can understand what is a consumer. What is a method? What does it contain? Public return type void. Name of the method is accept. Parameter is a t. Okay, so same way, fine. So you know the methods in all of them now. That abstract method, right? And all of them have similarly a abstract method. Okay, and so this is one set of fine. This is 8 of those 43. Okay, so we have 8 consumers like this. Then next is we would have this is, so return type void is one category. Another commonly used thing is like we have consumer, there's a opposite one where they don't take any input. This was saying no output, right? There's no return value. This one says, oh, I don't have any parameters. Okay, so if I don't have any parameters, but I'm returning value. So based on what is the return value, I'll have the method names. We call them as suppliers. Okay. No parameter. So abstract method doesn't have a parameter. They will have a return type. Okay, called as suppliers. So these are the suppliers. So what kind of suppliers do we have? One is a supplier. And, one is the supplier of some type T. Okay, fine. We'll see what is the method name. Okay, method name actually depend on the return type in this case. But anyway, there is a common way to find out what should be the method name. There are 5 suppliers in all. These were 8 consumers, 5 in the supplier category. Supplier, we have the int supplier, we have the long supplier, we have the double supplier, and only for this supplier case we have something called a Boolean supplier. Otherwise we are only dealing with the int long double and the generic type. Okay, nothing else. Yeah. Okay, I'll just give you for this obj, right? The method signature is going to be, what should be the method signature? Public void, method name is accept, 2 parameters. What's the first parameter? Obj. It starts with obj. That means the first parameter is the reference type. Okay, that's a type parameter, and second parameter will be int. Okay, and so accordingly your I've just shown for 2 of them, but others you can understand from this now. Okay. So the whole idea is we are covering all the kinds of methods, signatures, commonly used method signatures. Method name is standardized. Okay, fine. In this case here, fine, method names will be For the first one, the method name is get. Here it is public, return type T, method name is get, no parameters. So this is all about return type. I'll just show for this int get as int. So method name depends on, it starts with get, that's the only thing, okay. For the one which is with only for reference type, having only a type parameter, it just says get, otherwise get as int, get as long, get as double, okay, but no input parameters, right? Parameter list is blank, okay. Fine. Okay, fine. Next category will be, okay, okay, so it will be get as in, get as long, get as double, yeah. And now if you look at the next category, right? Next category is return type boolean. Okay, they will have inputs, but return type is boolean. Okay, called as predicates. We call them as predicates. So these are basically for testing. Take some input and get a test value of return true or false. Okay, so in this category, again, we have 5 predicates. So there are 5 kinds of predicates. We have a predicate of some type T. Okay, we would have this would take return boolean. Yeah, return type is boolean. Name of the method would be test, and parameter, it's T, right? Similarly, int predicate, return type boolean, test, parameters int, like this. Long predicate, double predicate. Okay, we even have a by predicate of T comma U. Okay, so 2 inputs. So your method will remain same, fine, returns boolean, but there are 2 inputs to this, T and U. Okay, so those are the 5 predicates, fine. So okay, fine, this is one category. Next category is function. So I have input. Achha, method name. Now you can see the method name is test always, right? In the above category, method name is test for all of them. So methods having input parameters as well as a return type. Okay, so yeah, so this category is called function, and this category is function. So in the function, yeah, what are the things? So first thing, you say function which takes some input T and returns a value of type R. Okay, if I have to put the method signature, it would be public, fine, method returns R, name of the method is apply, parameter will be of type T. So that's the input. So this is the first most simple thing. Okay, fine, most simplest method signature. Method names depend on the return type now. Okay, so you can say this is function of input is T, output is R, return type is R, right? Parameter type is T and return type is R. So same way we would have like function, we would have yeah, what do you suggest? What should be the other functions? Function with which involve primitives. Okay, fine. Okay, fine. If it involves primitives, then we have three primitives: int, long, and double. Right? Fine. So we have something like int to long function. What would it be? It will just say method would be int to long function. The name suggests what it should be, long. When the return type is long, the method name becomes apply as long. Parameter would be int. Right? It is int to long function. Clear? Just like int to long function. Now let me put the whole list now. Okay, what are the other combinations? Int, long, and double. Three things have to be involved. So we'll have the into double function, then long to int function, long to double function, okay, double to int function. So you, whatever method signatures commonly used, everything is available as a one of the standard function interfaces. The whole idea being, because we have one set of standard function interfaces, my API, when I write the library, I will be dependent only on these. I'll use these things which are from this standard set of function interfaces. Okay, so a library is built on top of this. So everywhere, why this is important, okay, is because this is what everything, entire other library is entirely dependent on. Okay. Okay. Fine. So method name is starting with apply but dependent on the return type. That's what you should understand. Okay, fine. So this is a combination of the primitives, right? Then we will have a combination of primitive and the reference type parameter. So we will have something like saying to int function of a type T. Fine. You get what is the method signature? Public return type int, apply as int, parameter will be T. Okay, so combination of primitive type and reference type. So this will be to int function of T, that way to long function of T, to double function of T. Fine. Other way around, parameter should be of type primitive, return type should be a reference type. Okay, so that will be called as int function of some return type R. Okay. Public returns R, name of the method is apply, parameter is int. Okay, same way we have the long function of R, we have the double function of R. Okay, fine. So this finishes one input, one output category. Okay, we have methods taking two parameters and returns one value. And these are all, all these methods have only one input and one output. Now we'll have two input and one output. Okay, so for two input, first thing, by function. We call it as a by function of T comma U comma R. Okay, so if it's a by function, return type R, method name is apply, parameter is T and U. Two inputs but returns R. Okay, so that's a by function. Fine. We have the to int by function. of t comma u. Okay, fine. Return type will be int. Apply as int. Parameter and u. Two inputs. Right? So all these are nothing but two input methods. Okay, you may be returning a reference type to long by function. Okay, and see how many we have done. How many functions? There are 17 of them. Okay, fine. So these are 17. Fine. Earlier we covered 18, 17 plus 18. And again, special case of uh, function types where input type so input and output types, if they are matching, right, we call them as operator. Fine. So we have something like a unary operator. Okay, fine. Unary operator of some type t. See, this is a special case of function. Fine. In function we have t and u as separate types. So here it says yes, they both match. Okay, so method name anyway, and the method name is apply. It's actually extending from function only. Okay, I'm just listing the names of the interfaces here, function interfaces. Yeah, okay. So these are all having that method starting with apply. Okay, we had the int unary operator, long unary operator. You have the double unary operator. Okay, in same way we have even the binary operator of some type t. So input output is same, two inputs which are of type same, and return type is same. Okay, fine. So same way we have the int binary operator, long binary operator, and we have the double binary operator. See, right? See, if you go systematically, you can cover all 43 just like this. This is, we listed 43 function interfaces based on the method signatures. Right? This is how they have been categorized. Okay, this is what has been used throughout the API. There are many advantages of these function interfaces. They have even got default methods, so interaction between two of the function interfaces is also possible. Right? We will be having a look at all of those things also. Fine, as we use all of them. Fine. Okay. So any questions? Yeah. These 43, I think the list, anyone can just build it just like this. Fine, clear? The 43 function interfaces. Okay, this I think let me just continue here. What was this is what we have already done, right? Method references and the constructor reference. Yeah. Oh, the categories: consumer, supplier, predicate, function, unary operator, binary operator. Fine. These are the, okay. The name of the abstract method is accept. That's a consumer. Okay. There are 8 consumers. So this 43 list is available. Anyway. Okay. These are the 4 suppliers. Then we have the name of the abstract method is test. These are the predicates. Somehow it's going to outline every time. Yeah. Okay, it's bringing up the outline. Then we have the function categories, which are 17, right? For combination of 3 primitives in int and long. Okay, we have the function tr. The order is slightly different from what I had shown. That's the only thing. But yeah, these are all just nothing but those, whatever I have listed, same thing. Unary, int binary operator, fine. Okay. We have the date and the time API. This I think we can take it tomorrow, fine. So the change related to the date and time, that's what we will take tomorrow, I think. Because here we have these. Okay, so update the account.transaction class to use the local date class. Okay, that is fine. Anyway, tomorrow I'll take the something related to the date time also, and then we'll continue with our tomorrow's thing is about some of the classes where all of these most of these function interfaces have actually been used. Okay, so the new classes or changes to the existing class and interface. Basically, one of the things is related to the comparator. Okay, comparator, you understand, it is useful for sorting, right? Getting ordering, fine. So for getting ordering in different manners for a particular class, given a class, or you want it to be the elements to be sorted in different manners. So you have to provide the logic for ordering. Okay. So for that purpose, yes, there is comparator. In comparator interface, we have lot many methods, static methods, which have been added to make our task easy to create a comparator. Static methods have been added in the comparator interface. Okay, we'll be having a look at that also, right? And we'll see how a comparator can be easily created. Right? You know, I had shown that syntax already, method reference syntax I have shown, and I have shown how a comparator was passed, employees.sort, right? Arrays.sort, and employees was a parameter, second parameter was a comparator. And to create a comparator, how to create it very easily for any given class. That's what we'll be seeing. Okay, and then okay, we'll have a look at the the API related to the date and time tomorrow. Okay, then any questions you have? Yeah, any questions? Yeah. Try out the exercise, that's one thing. Yeah, any questions? See, in this list of function interfaces, what one signature which has been missed out, right? Which is that signature which is missed out? One common method signature. We have input and output, right, in all cases. So if you look at the consumer category, yes, return type void, but it has some input, right? It has to consume something. Okay, what is missing is where there's no input and no return type void and no input. And what is that interface? Which has no input and no output, return type is void, and no parameters as input. Which is that interface? And it's a function interface. Because it's already part of the library, and so it was not separated out here. Okay, but you may find it being used in some of the APIs. Lot many places it's already being used. Wherever you have a function needed with no input and return type void, no parameters and return type void, which standard function interface would you use? Yeah. Runnable is the one. Clear? Okay. And so runnable, right? We know the method signature, right? Public void run, no parameters. Okay. And so the runnable, that also you should keep in mind. So some places you might come across this also. Some API says, okay, I need a parameter which is a runnable type. Basically, it's about, there was one statement initially when we started with function interfaces. It says, oh, functions have become first-class citizens of the language. What does it mean basically? In Java 8, functions have become the first-class citizen of the language. What? Yeah. Yeah. So, just like, values which were being passed around as a return type, as a parameter, objects were also being used as parameters, as return type in methods. You manipulate them. Same thing with functions. You pass around function definition here. Function definition is not part of a class definition only now. Within a method itself, you are saying, okay, I want this method definition here. Fine, let me create one object which has this method definition and pass it around. I'm returning a object which is again a function. Right? Fine. Does it not look like that? When you use Lambda expression, it looks like just a function definition. Lambda expression is just a function definition. Object containing a function definition. Okay. So that's what, like, you are treating it just like any other type. Otherwise, as far as methods were concerned, they were always embedded, right? In a class definition, in an interface, it's embedded. Oh, this interface has this list of methods. But we now have methods or function definition, which is local to a method definition. Within a method, within a constructor, any place in a static block, any block you are writing, or you are creating a function definition and just creating and using it, passing it around like this. Okay. And that is what was the meaning when it said, oh, functions are now first-class citizens of the language. And when someone says functional programming, it is basically this. This is what is the whole idea. That functions become as good as any other kind of an object. Right? Any other type. So function is a new type you can think. Yeah. Okay, any questions? Yeah. But you have to try those exercises now. Okay. I'll push whatever code changes we have done today. Okay. And yeah. And these notes also, whatever updates are there to the notes. And yeah, and even this one, this PDF for the today's. I think there is some problem with the PDF where it's repeating that, outline is repeating again and again. So I'll see how it can be taken care. And I'll update it and then put it. somehow, every alternate page, the outline was coming up. So any questions? Yeah.
Sir,
Yeah.
sir, in functional interface, when we write like hash code or any this method of object class, so there are default. I mean, there are default methods.
Those public methods in a function in an interface, right? Basically, in any interface, if someone puts a public method of the object class, fine, you're talking of that only, right?
Yes, sir.
Okay, fine. See, what happens is every type is a subtype of the object class. So, okay, actually, there are certain things I should say. Acha, okay, okay. I think, yeah, yeah. It lasts only this much. My mic charge. Okay, anyway. So object class is actually the super type for all the reference types. So even if it's an array, it's coming under object. Okay, you have object O equals, you can have array, you can have any data type here. Right? Object has those methods with implementation. Fine. So hash code and all those were public methods. If it's a protected method, it's not inherited. That's what we understand. Okay, fine. Protected is not inherited outside the package. Outside Java.lang, it won't be inherited. So therefore, you have to override and make it public. Okay, fine. So fine. So implementation would not be inherited straight away. Fine. You can use super and use it. Super dot method name, super dot clone, or super dot we have finalize, right? Okay.
Okay, sir.
Yeah. So interface are allowed to declare abstract methods, even for something which is available in the object class. But it's in general, this is what is happening. Okay, you see this. There is a method in superclass, someone makes it abstract. Not a good idea though. And says, okay, I have abstract class now. Yeah. Okay, any other questions? Yeah. Yeah, any other questions? I think, yeah, we should call it a day. My mic gets discharged. Okay, so thank you everyone. And thank you. See you all tomorrow morning. Okay.